Welcome to the second lesson of the quantitative chemistry topic. In this topic, the key questions are 1. How does mass change when gas products are formed in a reaction? 2. How factors should be considered in chemical measurements? Key terms that you need to be familiar with: mass change, gas formation, measurements. In today's lesson, we will talk about the gas-forming reactions and chemical measurements. Certain chemical reactions occur in a way that indicates that there is a change in mass during the process. However, the principle of mass conservation still applies. This strange discrepancy applies only when a reactant or product is a gas. Therefore, it can escape. Therefore, its mass cannot be taken into account. An example: when a metal carbonate reacts with hydrochloric acid, the mass of the metal chloride produced is smaller than the total mass of the metal plus acid, as carbon dioxide has escaped from the container. Another example is the thermal decompositions of metal carbonates, where carbon dioxide is produced and escapes into the atmosphere. Task: now please pause the video and describe what happens when calcium carbonate is dissolved in hydrochloric acid. Hint: carbonates contain carbonate ion, CO3 to the power 2-. Extension: how could you test the principle of mass conservation? Now let's discuss your answers. The following reaction takes place. The sodium-calcium carbonate is reacting with the liquid hydrochloric acid, and solid calcium oxide and liquid water are formed as products. The third product is gas carbon dioxide. It escapes from the reactor and goes into the atmosphere. Therefore, if the mass is monitored on a weighing scale, the mass will be seen as dropping. If the carbon dioxide can be trapped in a closed reactor, then no mass change would be visible. Another way to prove the mass conservation is to collect. Scientific experiments always involve uncertainty and errors. Task: now please pause the video and try to list some sources of errors and uncertainty in a chemical experiment. Hint: there can be different types of errors. Extension: how could you minimize the error? Now let's check your answer. There could be experimental error or human error. For example, a data logger does not pick up all the signals, and that causes some error in the recorded data. Human error can include incorrect reading of temperature or liquid meniscus. If the same person carries out the experiment and the same error is repeated in the repeated measurements, then it brings a systematic error into the results. Errors can be minimized by regular maintenance of the instruments and repeated measurements. Larger sets of collected data, more repeated measurements, also decrease the error.